if I write down a function x or f and I do something like console.log hello world, and if I call this function, it's a perfectly valid function. But if I do like this, if I create an anonymous function, whether this will work or it will give error. This is an anonymous function without that name. It will work. Let's see. So I will open the console.log and you will see this is the error is coming. The reason is that JavaScript does not allow function to go without any name. But if I pass this function as a parameter to any other function, for example, if I create a function and if I pass here an anonymous function, then it's a perfectly valid function. It will not give me error because I am passing this anonymous function inside the function, then it's fine. But if I'm writing that anonymous function like this, it will not it will give error. Now to fix that error, let's say if I pass a parameter, it will give error because anyhow this does not have the name. So to make it work, I will pass the round bracket around this function. If I pass round bracket around the function, then it becomes a perfectly valid code, JavaScript code, and it will not give error now. Let's see. If I refresh now, I am not getting an error. Now I am also not getting the console.log of the hello world. Why I am not getting the console.log of hello world? Because this function is created without invoking it. Every time when we create a function, when we have to call this function, I cannot say f. I have to say f and round bracket to invoke the function, to make it call the function or to run the function. Similarly, I created this anonymous function, but I am not running it. I am just created this function and that's it. It's lying there, but it will not work because it is not invoked. Now to invoke this function, I can pass the round bracket like this with some number because it is expecting one parameter, that is x. And if I invoke it like this, it is a self-invoking function and it will immediately invoke as soon as the page will load. Now if I refresh, it's saying hello world 4 because I am passing here 4 and it goes here 4 as the x as a parameter. Now what if I pass this round bracket outside the round bracket? Because I have a function here inside the round bracket. Inside the round bracket, I have a function. I am invoking that function using the round bracket and passing some parameter. Can I do same thing by moving this round bracket outside this one? Yes or no? Yes. So either way, I can put this round bracket outside this round bracket, or I can put this phi inside this round bracket, but this round bracket should be after the function curly bracket ends. So here the curly bracket ends and I am invoking that function by passing the parameter phi. Now if I refresh, it's saying console.log of phi. It says console.log hello world of phi because now I'm passing it phi. Now what happens to this x variable? This x variable is showing phi number and this is purely local to this function. And in the memory, it has a separate space of this x variable, which cannot be replaced by any other x variable, which cannot be replaced by any other value because it is local to this function. Let's say if I call this one and a separate function with a separate 4 parameter, if I pass 4 as a parameter, so this x is a separate variable in the memory. This x is a separate variable in the memory, though their name is same. When I run this code, each one will show its own value. So if I refresh it now, okay, not a function. What is not a function? Wait a minute. It's saying not a function. What is saying not a function? Intermediate value is not a function. Okay, let's refresh again. Okay, maybe I missed a semicolon, so it was considering the same thing. So now if you see in the line, it's saying hello world 5, and the second line is saying hello world 4, because both x values are separate in the memory, though the name is x, because this function is creating a local space inside this part, and the x value inside this function is separate from this x value, because this is creating a local variable x inside its scope. The scope of this x is only this function. So you will see this x value is in the memory is different from this x value in the memory, because this is the x value inside this function which has a scope of only this one, and this x value has the scope of only these two lines of the code. So both, though the name is x, but in the memory have a separate location, and so they can store different values. So this is something which you have to understand before we jump to again to the closures. Now, once you got this point, which I explained just now, let's go to the closures again. Here is my function, closure function f, and I start with variable a equal to array. I will say var I, and I will loop the I equal to 0, I less than 3, I plus plus. Now, if I say a of I is equal to a function, first I am showing you the bad thing, that is the incorrect thing, and I say return I, and here I will say return a. Now what happened? This is the function. Inside this function, we have another function which is returning to the global space. And since it is returning to the global space, generally we don't have the access of this I value in the global space. But since it is a closure, it is returning into the global space. So I have access of the I in the global space. So when I say return I will be getting the value of I. So first time, it's a 3 times. So first time when it runs, now when I invoke this function, for example, var a equal to f. Now when I invoke this f function, it will return this function. It will return the a. So we have a of 0, and we have a of 1, and we have a of 2, because this for loop runs 3 times and it returns a. So we got a in 3 values, and this a will consist of a function which will return the I. Now when first time it will run, I value will be 0, second time it will run, I will be 1, when I will become 2, third time it will run, and once it will run third time, I value become 3, and it will check if I is less than 3, and it will not run because I value has become 3. So in the memory, what is the value of I? After I run this all for loop, what is the value of the I in the memory? In the memory, it is 3. So now, after this call, the value of I in memory is 3. Now I run a of 0 as a function. Since the value of I in the memory is 3, when I run a of 0 as a function, and when I run a of 1 as a function, or when I run a of 2 as a function, in all 3 cases, it is written I, and the value of I in the memory is 3. So if I run this one, Okay, I have to do console.log, otherwise this I won't be able to see the I. I'll do console.log of a of 0 because it is returning, but we have to console.log of the values. So it's saying 333. Now I explained you why it is 3, because when this function runs, the value of I already become 3 in the memory. Now whenever I call a of 0 or a of 1 or a of 2 as a function, this is returning the value of I, and value of I is 3 in the memory. Since value of I is 3 in the memory, we get always 3 here. Is it clear till now? Okay. Now, though the value of I is in 3, let's say for a few minutes I don't consider what is the value of I in the memory, but you get the concept of the closure, that this function which was created inside the function f is now can be accessed, the variable I can be accessed from the global space using these 3 lines. So it is 3. Let's say I don't mind it 3. Let it be 3. What's happening? Let it be 3. I am okay with the 3. But I am able to call the I value. I am able to access the I value in the global space. Is it true or not? Yes. Because here when I do console.log, it is showing the value of I, and since the value of I is inside this function, in reality it should not be accessed outside this function. But because of the closure, I am able to access the value of I in the global space. Since I am able to access the value of I in the global space, that is called closure. So if you understand that since I am able to access the value of I in the global space, I am using the closure. This is the closure. Though its value of 3, forget about the value of I equal to 3, but since I am able to access the value of I in the global space, that means I am using closures. And I am successfully able to access I in the global space, that means I am using closure successfully. And that is the concept of closure. So you now got to understood the concept of closure, but now we will fix the problem that if I want different value of I don't want the value of I want different value of the loop, whichever is moving, then we will try to fix it. But that fixing is not related to the closure. That fixing is irrespective of the closure. We have to understand what is the meaning of the closure. Closure is something moving this function into the global space so that we can access the value of I in the global space. That is the meaning of closure. So if you understood this part, that since I am able to access I in the global space, you are good to go. That you have understood the concept of the closures. So in exam or in interview, you are only required first to understand the concept of closure, which you understood, because you are thinking that I can be accessed in the global space. That means you have understood the concept of the closures. Now, since this function is a problem, since it is looping, so we have to fix the problem that instead of I, it should go as a 0, 1, 2 value, rather than it goes 3 value in the all cases. Now this I is in the memory, and this I is called a free variable. Since this I is called a free variable and its value changes when I run the for, and we get the latest value of I in the memory when I run this part. Now to fix it, we have couple of methods to fix it. Let's say if I use let statement, which is EA6 function of JavaScript. Let's say I create a variable called as let j equal to I. If I say let j equal to I, what happens? J is created inside this curly bracket, and j is not the free variable. Whenever one time loop runs, the value of j is again called as a new variable. So whenever I runs as a 0, j is a new variable. Whenever I runs as a 1, j is a new variable, because let is something creates a new variable inside the curly braces. So now instead of I, if I use j and then run the code, it is showing 0, 1, 2. because the value of I in the memory is 3, but the value of j is not 3, because j is created every time if I call this curly bracket. Since j is created newly every time we call this curly bracket, so we get the value of 0, 1, 2, 3 here. Because if we use let means it creates a new variable inside the curly bracket. So in the memory, every time this loop runs, the value of j is new. It is not the 3. When I created I here, I is a free variable. In the memory, its value increased to 3. That's the reason I was able to see 3 in the memory. And every case was showing 3. But if I use the j, if I don't create this outside loop, this one, if you use only var I equal to 0, then it is only one time. So in the memory, I value will be 0 and you will be able to see 0 here. Inside loop statement, you are saying inside loop statement, if you use I equal to 0 like this, you are saying like this. Can you write down the whole code which you want to run? Okay, so that is there here. It's there. Then declaring I outside. It's same thing. It's same thing. One and the same thing. Because the variable I, if I declare it here or if I declare it here, it's one and the same thing. So if I say I here, it is one and the same thing, and the value of I will be updated, because var is not like a let. Let is something which creates a new variable inside this curly bracket, and var does not create like that. And var is only considered as an initial statement. If I keep it outside or inside for loop, it is same. So if I use this one, it will give the same result if I am using I. It's 3 all the time. So to the fixing part is not considered as a closure. I am showing the extra step of the closure, how to fix that, but it does not consider that as a step in the closure. You got to understood the meaning of the closure. Closure is only moving the function from the function to the global space. That is called the closure. Now, but we have to fix this problem. So to fix this problem, I value become 3 in the memory of the computer in the JavaScript engine. That's the reason if I use I was always saying 333. But if I use j equal to I, that means if it runs first time, the j value becomes 0, and in the memory it is 0 only. So second time if for loop runs, the j is different j. It is not the previous j. So j is always new j whenever we run the for loop. So that's the reason if I use j, I'm getting value. Is it clear till now? Okay. Now what if I don't want to use ES6 version of the JavaScript, that is let. If I don't want to use let, if I don't want to use let, I will use the self-invoking function which we just now saw. We have to start with a round bracket, and I will start with the function, and this function will take parameter, for example x, and here I will return our old function, that is the function which I was previously returning. Previously I was returning like this. I was returning like this. Now I'm not returning like this. I will create an anonymous function and I will return the function here like this. And here instead of j, I will pass the x which is coming from here. And here it will be, it's a self-invoking function. So I can pass the parameter here as I. So now I is going inside this self-invoking function, which goes x as a x inside this function, and it will return the function called as return x. So now it is returning x. Now it is returning x and it is assigned to AI. Now if I run it, It's saying 0, 1, 2. Now why it's saying 0, 1, 2? The reason is when I put this self-invoking function, the value of x is a separate from the value of the previously. So if I is equal to 0, this value in the memory is different. When I will call as a 1, this variable x will be different in the memory. When I will call as a 2, this x value in the memory will be different. So in the memory, though the name is x same, but in the memory it creates a separate memory space. So we are getting separate value I in every case. So I am passing 0, it goes inside as a x, and this x is a new variable in the memory of the computer. So we are getting 0, 1, 2. Previously, if I was returning this as I was returning this I is same in the memory, which is this one. Since the I is as this one, so I was getting updated value of I when I was using these statements. But now, since we use the self-invoking function, and so the value of I goes 0, 1, 2, and in the memory it goes as a 0. X will go as a 0, 1, 2. Though the name is X, but in the memory it creates a separate location. So you are getting correctly 0, 1, 2 value. Is that clear? Any questions? Yes, because we got X, and X is in the self-invoking function. And since it is in the self-invoking function, the value of X is different in the for loop. So if we are running the loop 1 time, 2 time, 3 times, though the name looks X, but in the memory of the computer, it is a different value. It's a different space. So it's a different memory space. Whenever we run the self-invoking function, if we run 10 times, it will be 10 variables, though the name will be same, but the memory space will be different. This problem only I am showing you to show to the examiner, to the interview person, because he will be asking this question. So you should know the reason why it is there. But in reality, the closures end when you know that this function was written to the global space and it can access the value of I in the global space. That is the end of the closures. We did this extra step only for the interview purpose, only because they create this kind of problems to confuse you. And so you should not become confused. That's the reason we did the problem. But this is not the real closure problem. Closure we already did on that day, that any function which we create inside a function, if we bring it to the global space, it can access the variable inside the function, and it can also access the variable outside the function. Okay, now we will do lot more problems on the closures, so that you can understand closures very thoroughly. So let's create a new 2.html. So I'll be creating 4 or 5 more examples on the closures, which are similar to what we did, but we will do little exercise. We'll do little practice on the closures. So then the problem which I did here, I will rewrite this problem in a different way, but it is the same problem. I will create a function f. I will say var a equal to array. I will say var I will say var I for I equal to 0, I less than 3, I plus plus, and then I'll say a of I is equal to, I will create one function called as make closure, will pass the value of I in it, and I will return a. It is same thing, but we are creating this function, and I will this function here. Function make closure, it will take a parameter x, and it will return a function which will return the value of x. So this x is coming from here, it will return a function x, and we call this make closure. So this part is same as this part, only I did here anonymous function. Here I created a new function, but internal and whole concept is same. And when I call the same thing here, like this, and then I will run this in the browser. A is not defined, let's define the A. Here var A equal to F, I will call the F function. So now it's saying 0, 1, 2. The reason is we are calling the function, and this function is taking the parameter x, and since it is taking x parameter, it has its own local space in the memory, and so this x will not be same as previous x. So if I call first time, this x in the memory will be different when I call second time, when I call third time. It is same what we did here, only we called a new function, but the concept or the memory space is same. This x is newly created in the memory whenever we call this function. So whenever we call the function, the local variable is always a new in the memory. So you cannot repeat this x. So name is x, it is new in every case. So this is the second example which we did. Let's take one more example. 3.html. I'm doing lot more exercise of the closure so that you should be very thorough in the closure. You know what is going on. Let's say I create a function greet, and I will say what to say as a parameter, and I will return a function. Now forget about these two things. Forget about this function. This function was only I did it to show you how to deal with the interview guy. Only thing in the closure you have to remember is that this function goes to the global space. That's what I wanted to understand. So here we are not doing this kind of thing, which is only for the interview. We will be doing only the closure part. So I will return this function, which will go into the global space, and I can access the local variable also. I can access the global variable also. That is the concept of closure, and we are doing that thing. We are not doing now this thing. Now forget about this thing. This is only for the interview. Before you go for JavaScript interview, just revise this function again and again, because this is what they will be asking. I put it in the chat also. Now forget about this part. Take this as a new closure and try to understand this as a closure only. I will say function name, and I will do console.log of what to say, which is this one, plus space plus name. Now what I will do, I will run, I'll say a variable called as x equal to greet hi. When I run this statement, it calls this function and it will pass this hi inside this what to say, and then it will return this function. This function, it will return this function. Now when I call this greet, it runs all the lines of the code, and it is gone into the thin air. Once it runs all the lines of the code, it is in the air. We don't know where it is. The function is run. But this what to say is inside this one. So when I run this greet one, all lines are coded, I have run in the step by step, and then it is gone into the thin air. So when I see x, what will be the x? X will be this function. So when I run like this, x, I will put some name, for example, Tony. And if I run this statement, it is saying, hi, Tony. I'm not passing what to say here. I'm not passing what to say here. what to say was passed here as a high. Since what to say was passed here as a high, when these 3 lines of the code runs, actually what to say should be gone into the thin air. When I run this statement, what to say should not be there, because what to say ran when I run the greet command. But because this is a closure and this what to say is still in the memory of the computer or JavaScript engine which is running, so when I run this statement, though it is calling what to say, though I'm not passing what to say here, but since it's in the memory, somewhere in the memory of the computer, so it is keeping the high in the memory and it's saying high name. And since this what to say was called here, so that means what to say, this function is able to access this variable and it is able to access this variable in the global space, and that is called the closure. Why it is called closure? Because I am able to access this what to say, which was the local property of this function. I am able to use it in the global space. Since I am able to use the what to say in the global space and I am moving this function to the global space, and so this is called the closure. So this is one of the example of the closure. Let's uh, let's take another example. All are similar. When you see the closures, everything will be similar. A function will be created inside the function, and that function will be exported to the global space, and we can use the local variable also, we can use the global variable also. Let's take another example now. Go through all the examples, and so you will see the common pattern in all the examples. So I will create a function called as make counter, and I will say let count equal to 0. And here I will return a function to the global space since it is a closure, and I will return the count. I will return the count value plus plus. So whatever the count value is there, the return will be one more. Since this count is created outside this function here, that's the reason this function is able to access this count, because this count is created here. This is called a scope chain. Scope chain means if you create a variable in the function, all the internal variables can access that variable. But I cannot access this count in the global space. If I say console.log of count, it will give error. Let's check that one. Because that variable is created in the, see, it's not defined, because that variable count is created inside this make count. So I cannot access it in the global space, but I can access it inside here. Now if I call let counter is equal to make counter, so when I call this one, make counter will return this function, and so I will get this function here. Now if I say counter, maybe I can say console.log of counter. Now this is the return is a function, so I can call invoke this counter multiple times. So since I am running it multiple times, I'm 0, 1, 2, 3 value, and so that means though this count is inside this counter, when I'm running the counter, it is increasing that value, and that means it is increasing the value of this count, and it is in the memory, and it is created inside this function, and I'm able to increase the value outside that function. I'm able to increase the value of this count in the global space because of the closures, and so it is a closure, because and it is able to access the local variable count in the global space. Since I am able to see the count is increasing in the global space, that means I am able to use that variable in the global space because of this closures. Is that clear, this part? Okay, let's take one more example. We will do lot more examples so that All are similar. All are created in the global local space and exported to the global space. That is what you need to understand. I will create a new file, file.html. I will create a script and I will create a function called as make greeting, and I will pass the language. And here I will return the function. Every time closure is there, you will get return function. First name, last name. And here I say if language is equal to en, then I will do the console.log of hello plus first name plus space plus last name. So whatever language was passed, I will check. If language is English, then say this. And here I will say if language is Spanish, ES, then say hola. In Spanish it is hola. Now what I will do, I will create a variable called as English equal to make greeting, and I will make pass en value. And I will create another variable called as Spanish equal to make greeting es. Now once I run this function, the language which goes inside this part is English en, and it will run this step. And when I run this one, the language which will go inside this one is es, and it will run this part of the code. Now if I want to use the English, I will say English. I will say, let's say I will put my name, or I will say Tony. Tony is good now. Tony, and last name is, let's say, Bill. And here I will pass second one is Spanish. Here I will say Tony, and I will say Bill. So English is created in here with the help of this make greeting, and it is a function. And Spanish is also created using the make greeting, and it is also written the function. So when I call English, actually it is going inside this function with the first name, last name, and it is using the language which was trapped here. When I call this English part, or when I call Spanish, the language is trapped here in the Spanish. So now if I run this code, so it is saying hello Tony, hola Tony Bill. So though we are creating separate instances of make greeting, one is trapping the language English and another one is trapping language Spanish. And then if n number of times if I'm calling English, it is calling actually this function, but it is taking the language which was initially mentioned here in these two lines of the code. So in the memory, this creates separate space with the language of English, and in the memory, this creates a separate space in the memory of the language Spanish. And so whenever I'm calling it again, it is actually calling this function, but when I'm saying language equal to English, it is taking the language which was initially defined in the make greeting. So it is closure, because we are returning the function to the global space, and it is able to access the local variable called as language in the global space, that is the English or Spanish. So it is a closure. Let's take one more example. Everywhere you will see two important things. Function is returning to the global space, and we are able to access the local variable. Let's take the function make counter. This is different make counter which we did previously, and I'll say let count equal to 0, and I will return the function. It looks like similar to the previous one, but it has some different meaning. I will return count plus plus. Let's take this one where we did this one. This one is the counter, and I will copy this one. Okay, so I'm copying. this. Okay, so I'm calling make counter, and it's counter. For first time it will be 1 and then 2. So let's run this one. So it's a 0 1. Sorry, 0 1. First time it will go as a 0 and it will return it. Second time it will go as a 1. Now what will happen if I create another one that is called as, let's name this as a counter 1 and name this as a counter 2. And I call counter 1 here, counter 1 here. 2 times I'm calling counter 1 and 1 time I'm calling counter 2. So what will be the value here? What will be the value here? What will be the value here? Tell me all the three values. So this is calling counter 1, this is calling counter 2, this is calling counter 1. I created counter 1 with the make counter. I created another counter 2 with the make counter. What will be the value here, here, here? Give me three values. 0, 1, 2. Another person? So if I save this and if I run this, it is saying 0, 1, 0. The reason is, when I create this, it will create a separate instance of this make counter in the memory. So I'm running counter 1, it will say 0. And if I'm saying counter 1 again, it is giving 1. And when I'm running this counter 2 is also calling this same function, but then this is a separate instance in the memory of the computer. So this counter 2 again starts with the 0, 1 and 2. So if I do again this counter 2, 2, 2, 2, so it will start again from the 0, 1, 2, 3, 4. If I create another instance called as counter 3, it will again start with the 0 and it will say 0 again. So when we are creating make counter, it creates a separate instance of that function in the memory, and so you get the count as a separate. So this count is not same in the counter 1 and counter 2. This count is different in counter 1 and counter 2. Okay, let's take another example. Now I will, after a few examples, I will give you exercise so that you have to do that part. This is another example. Here also I will ask you something. Now I will say here, let name equal to John. And I will say function say hi, and I will do alert hi, and I will put plus name. So this name can be accessed from here because this is in the global space, and global variables can be accessed inside the function. So I can access it. So for example, if I say hi, it will, so it's saying hi John. Why John is saying? Because John is in the global space and I can access that global space here in the function. Now if I say name equal to Pete, and then if I say hi, what will be, it will alert hi Pete or hi John. Though this is not the exact closure, but a different question. It will say hi Pete because the reason is Pete is it's saying hi Pete. The reason is it will take the latest changes. So if name is updated with a different value, then in the memory this name is Pete, not the John. So it will show, though this function is written before this one, but when I say hi, it will take the latest value in the memory, which is Pete. So you have to think in the memory, what will be the value in the memory? Though this function is called before this name, many people will say, okay, name is called here and name is here. So this name will not affect this function because this function is taking the name from here. But this is wrong. This name is coming from the memory, and you have changed the value of the name in the memory, so you will get this one, not this one. Okay, similar to this one. .html. So I will create a function called as make worker, and I will just say, I will say this one, I will put it inside this one, and here I will return it function. It is returning function, so remember it is a closure, and I will say alert name. I created a name here, I return this name, so this function can access this name. So if I run this one, it will actually alert this John, because this is the value of John. Okay, or let's name this as a Pete. Now I will say let name equal to John, and I will create this one, let work equal to this one, this function. And then now I will call work. Since it is returning function, I have to invoke the work. Now what will be the alert one? Whether it will be Pete or John. It will be Pete. The reason is in the previous case we have the Pete as a global variable like this. Now it is the local variable. So when I return this one has no effect on this one, because this one is taking this name. So let's check this one and see how it goes. So it's saying Pete, right? Because Pete was created inside this local space, and so it will take that Pete, not the John. Now what if I delete this part? Whether it will give error or it will do something different. What will it do? It will say John, because then it will take the global one. So now if I refresh, it's okay, wait, it's saying Pete. Wait, it should not say Pete. Maybe it's not okay. Let's copy this in the, because sometimes it caches the thing. So it's saying John. Somehow it caches the thing. So many times I've seen I have to create a new tab and I have to call the John, because since now John is the global space and we're returning this name, so you know that when we return this into the global space, it can access the global variable, it can access the local variable, and it can access both the variables. But here the special case was, though it is similar to the previous one, but the previous one we have Pete outside, now we have Pete inside, so it will take this one, not this one. Local has more preference over the global. So whenever we have local variable, it has more preference. Now, little tougher problem, and you have to do this one. I will create 9.html. Sorry, 9.html. Let's open this one. Now, you have to create a function. I will give you the how I am invoking it. You have to create a function that is called sum, and whatever blah 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 blah, whatever you want to do, you do it. I will call this sum function like this, 1, and I'll say 2. When I do console.log of this like this, it should give me the result of 3. At another one, if I pass 5 and -1, it should give me the 4. So you have to create a function sum. Create a function sum with as many parameter you want, maybe 1, A or B or only A or nothing, whatever you feel. Just create this sum function and it should work like these two. Do create this function and put it in the chat. If you don't know, I will tell you. I'll give you 2 minutes to answer it. You don't need to invoke this function. Invoke done here. You have to just create the function. So this function, you have to write down this function, but you cannot invoke the function because invoke part is done here. In the example which we are showing, you are invoking. Okay, let's see Sindhu. Number 1. Yeah, so this is what I was expecting. What Sindhu has written here. For example, I create a function sum. I will put it A, and then I will return a function with the value B, and here I will say return A plus B. So what happened when I call sum1? Forget about this 2. When I call sum1, it will return this function. Since it will return function, that means this is a function. So the return part of this is a function. So I can also say like this: var x equal to sum of 1, and then I can say x of 2, because when I say x of this sum 1, it is returning this function. So when I run this x, that means I am running this function. I am passing the second value, that is 2. So this a value is already captured here. So it is going from the captured value 1, and second b value is going from here. So it will give the return of a plus b. So to summarize or to make it in one line, we can also say sum of 1. It will return a function, and I can immediately write another round bracket, and I can say 2. So this part will return this function, and we are immediately invoking it with the 2. That means we are passing b as a 2. That is written a plus b like this. So let's run this one, 2 lines, and see. Okay. So it's saying 3 and 4. So the reason is when I say sum of 1, I'm getting this function, and then I'm invoking sum of 1 with the parameter 2. So b is going as a 2. So I'm getting 3. Here in this case, sum of 5, I'm passing sum of 5. It will return this part, and when I immediately invoke it, that means this is the function because it is returning this function. I'm invoking it with the new value, so b goes as a -1, and we get 5 minus 1, that is 4. And these both have different memory space. That's the reason both are not colliding. Both are giving different results. So this one was the last exercise in the closure. You can go through all the videos again, 1 time, 2 times, 3 times. This example is only for the interview purpose. This is not really the closure which we try to understand. We did some understanding of the closure on that day. That is what closure is. This is only to answer in the interview question. I give this one. But this is not really the closure, meaning of closure. Meaning of closure I showed you on that day. I will repeat that meaning again. We have global space. Then we have another function. Inside that we have another function. And here we have the variable of b. This is the b. This is b. When I move this function outside this function to the global space, such that since it was created lexically here, it can access b, and now it is moved to the global space. Here also it is able to access b, because we know that function can access a variable in the lexical scope only. Since it is created here, it can access b even if it comes outside of its scope to the global space. Then also it is able to access b. That is called closure. So this part is called closure, and this is only the exercise which we did for the interview purpose. So don't think this is a real closure. Real closure is the one which I explained you previously. So go through this video again. Try to see all the examples again 2-3 times. And if still you don't understand the closure, then I will explain you again on the Monday the part which you don't understand. Just remember that closures are little difficult to understand in the beginning, but when you do lot of exercises like we did today, you will understand it in better way. Only thing, just remember, function returning to the global space, and it can access the local variable. That's it. That is called closure. That's it for today. Any